Okay, I'm on page 38 of the class notes, where we left off with fronts. And what I'm trying to do at this point is just make a series of smaller videos just about smaller topics, just little things that you should be aware of. And one of them is this idea, well, we see rainfall in certain areas. Some areas are obviously drier, and some areas are obviously more moist. And one situation that you should be aware of is something called orographic lifting. Okay, orographic lifting is a situation where precipitation patterns are influenced by mountain chains. Okay, so if we take a look at a situation, this is a very typical situation. Here we've got the prevailing westerlies. These are the winds that blow from the west to the east in the United States. Okay, they blow from the west to the east. So in this example, maybe we're talking about the Pacific Ocean somewhere. Maybe somewhere in the Pacific Northwest, maybe Washington, Oregon, something like that. And what happens is the Pacific adds a lot of moisture to the air. And because of the prevailing westerlies, the wind is blowing the air into the mountain. And the air really has nowhere to go, so it gets forced up over the mountain. And so the wind pushes the air mass into the side of the mountain. It has nowhere to go but up. Now, when this happens, we have air rising. So the air rises, and when it rises, it cools, it expands. So it cools two ways due to the environment, meaning it's cooling because of altitude, but it's also cooling adiabatically. And this is because it's expanding. So it cools, eventually it reaches the dew point, and we end up with clouds. So I'll draw some clouds in here, which means that on the, what we would call, windward side of the mountain, we have rain. Once the air crosses the top of the mountain and starts to come down the backside of the mountain, now we have a different situation. Now the air is sinking. Instead of expanding, it's getting compressed. Remember, when we compress a gas, it gets warmer, and warm air can hold more moisture. We're moving further away from the dew point. The air is drying. So we're not going to get any clouds. Really, no clouds, which means no rain. So on the, what we would call leeward side of the mountain, leeward means it's protected from the wind. The leeward side of the mountain gets very little rain. This is a very dry environment. If it's for the Pacific Northwest, this might be a city like Spokane, which is essentially a desert-like environment. Whereas on the Pacific side of the mountain, you might have a location like Seattle. And I'm sure that most of you are familiar with the idea that Seattle gets a lot of rain. And this is why. The wind comes off of the Pacific and then gets forced up into the mountain. As it rises, it cools, it expands, it cools, reaches dew point, we get clouds, we get precipitation, we get lots of rain, and we end up with a lot of rain for a place like Seattle. But again, once the air moves over the top of the mountain, then it does the opposite of what is needed to form a cloud. It starts sinking, it's getting compressed, it's getting squeezed, it's warming up, it's drying out, and you're not going to get any clouds on the leeward side of the mountain. And this process, again, is called orographic lifting. is something that you need to know a little bit about. So mountain chains will determine areas of rainfall. And we see this all over the planet. Where the prevailing wind is blowing into the side of a mountain, you get a lot of rain. The other side is typically very dry. And that's orographic lifting. It's not only in the United States. It's located, we see this wherever there's large mountain chains. Okay. Latitude is also going to determine areas of moisture and areas that are dry. And I think I talked about this a little bit in one of the other videos. If we pretend that the Earth is tilted on its side in this case, and let's say that this is 0 degrees, it represents the equator. So now we're looking at the Earth sort of on the side. And now we have 30 degrees north, and here we have 30 degrees south. Because the equator receives a lot of direct insolation, because the angle of insolation is very high, we're getting a lot of direct sunlight near the equator, it's going to get very warm. And warm air rises. Remember, it rises and then it cools, it expands, and yet again, we get clouds. And this is why we have tropical rainforests at the equator. The air rises, it hits that dew point, and we get lots of clouds, okay, with the rain associated with that. We also see convection. The air rises, and then it has nowhere to go, so it cools, it goes out to the sides. Eventually it's going to start to sink. Go back around again, like that. Now, sinking air again is warming air. It's getting compressed. It's getting squeezed, which means it's getting dry. And this is why at 30 degrees we get our deserts. At 30 degrees north and south, we get our desert locations. Some of the driest places in the world. Atacama Desert in Chile can go years without even getting a drop of rain. So at 30 degrees north and 30 degrees south, we get tremendous amounts of, desert environments, dry desert. And then we get tremendous amounts of rainfall at the equator, obviously. It's almost constantly in a shroud of clouds. Now, there's a term called the doldrums. And this is the region where the warm, humid air rises, and because of this, we get rain all the time. Nobody really says this anymore, but sometimes people will say, like, if you're kind of down or upset that you have a case of the doldrums, maybe like your grandparents might say that. Basically, stormy weather. I mean, I don't really hear people say that very much, but older people sometimes say that. It was an expression from, the past. So, then we also have, well, you know what, let's stop with that for now. Okay, so anyway, those are a couple of factors that will affect rainfall and why it rains in some places and not other places. It doesn't rain evenly everywhere. Some places are drier, some places are moister, and these are a couple of reasons why.